Okay, this is take number 3, the video. It's Monday evening, and I was going to already have this video up, but I'll have it up in time for you to use it in week 2. Uh, that's when you need to see it. We're going to talk about a video that is for the week 2 uh, tailgate, and I'm going to use that video in conjunction with what you're looking at here on finding the volume of a cylinder, because you're going to need to know all those things for this course. Now, the video itself we will switch to it momentarily if I don't mess it up with my challenged IT fluency. And then we will focus on the video after we talk about this, calculating the area of a cylinder. Mainly we're doing that so we can eventually find the volume of that cylinder. So heads up here, I'm going to work through this a little bit with or without you. And please, text me if you say what. And but I'm not going to carry on a conversation with you because I'm going to be doing 2 things, and that is my max. If I attempt to multitask 3 different things, I'm done. I'm going to mess it up. So stick with me on this. So let's start out with this, find the volume of a cylinder. Now, when I talk about a cylinder, I'm going to tell you why we're going to talk about a cylinder, because what makes the bucket open and close on a backhoe, on an excavator, what makes the booms go up and down, the lift arms on a loader, well, it's hydraulic cylinders. A cylinder is a linear actuator. A hydraulic motor is a rotating actuator. It goes around and around, similar to the torque converter in an automatic transmission. But we're just going to stay focused on these cylinders, and what we have here in hydraulics is we have a fluid that transfers energy to a mechanical device such as a bucket or a cylinder. And we're going to be talking about that all during this course. But we want to get this out of the way. The book won't go into this until a little bit later. We're going to get this calculating the area thing out of the way, because the guy's going to talk about it. That when I say the guy, it's a little cartoon fella in the video. I like the video really well. So I will, when we get to it, I may pause it and talk about what he just talked about, or talk about what he just might talk about. So for now, let's look at this right here, finding the volume of a cylinder. And we don't necessarily have to find the volume. We might talk about it in a minute, but we are going to know how to find the area, because that's the volume. Volume equals area times depth. Now, really don't want you worried about depth right now. Does that T need crossing? Well, it is crossed now. So area equals, this is pi, right? Remember that from somewhere? Pi is 3.1416. To find the area of the, when I say piston or cylinder, I'm talking about the area of the inside opening, the inside diameter, or which is the same as the outside diameter of a piston. So we're gonna, that's where we're gonna start. We're gonna start how to find the area of a circle, let's just say. Now look at my formula right here: pi times the diameter squared divided by 4. That will get you the area of a circle. Or you can take the square of the diameter, like here I'm going to use 2 inch, and multiply it times 0.7854. Where does that 0.7854? Because that's what the fellow in the video is going to use. He's not going through all of this. But just right quick like, let's just take this part right here of my formula, because that's what he's saying. He's saying if I do this, I will be doing the same, multiply this times the diameter. I'll be doing the same thing. So what is this? Pi divided by 4. Well, pi is 3.1416, isn't it? Of course it is. Let's divide that by 4 and see what it equals. I do have a calculator lying around. Which one do I need? I've got too many calculators. I'm going to use this one. 3.1416. 3.1416 divided by 4 equals, look, 0.7854. So instead of going through this pi divided by 4 and multiplying it by the diameter squared, let's just take the square of the diameter and multiply it by 0.7854. Okay, let's do that. That's what he's going to do, the little cartoon guy in here. That's what he's going to do. If you want proof of this, we could go through the whole thing here, like this right here would be, I could say, well, wait a minute. Let's prove it this way. Let's take the diameter squared of a 2-inch cylinder. So what is 2 squared? That equals 4. So let's I don't want to crowd you up here, but let's take the diameter squared times, and that's what he's saying, or I'm saying now, d2 times that will give you the area. D squared times this will give you the area. So that's 4. So let's multiply 4 times, let's see, let's multiply 4 times 0.7854. 4 times 0.7854, that equals 3.1416. And I think that's what we want it to equal. 3.1416. Now let's go over here and let's take this thing right here. 3.1416, that's pi, times the diameter squared right here, and we already know the diameter being 2 squared is 4, divided by 4. What does that equal? Well, let's see. The old-timey calculator. Let's clear it out, and let's take 3.1416 times 4 equals 12.57, I'm going to call it. This equals 12.57. This is looking pretty shaky. And let's divide that by 4. It's scary when I really don't know what's going to happen. I'm just going to clear it to be safe. 12.57 divided by 4. 12.57 divided by 4 equals, yay, no, 3.1425. I've made a mistake somewhere. I rounded it off. I'm going to change my calculator so that won't happen. So here we go again. New calculator, as if that's going to make a difference, huh? Turn it on, clear it, and let's put in 3.1416. I don't know if you can see that, but I really do have it in there. There it is, kind of up at the top, 3.1416. And I'm going to multiply that times 4, and that equals 12.57 divided by 4 equals 3.1416. I'm not making this up just because I made a mistake. I'm just didn't round off my decimals, and it made a difference. So you see, 3.1416. Same deal. This is D2. So from now on, I think we can safely say that to find an area, we can take the diameter of the piston or circle, if you will, square it, multiply it times 7.7854, and we will get the area of a circle from this point on. Now, if you want to go back to old school, you're welcome to do it. It's taken me forever to get to today, to where I'm trusting this 7.854, but I've done it 2 or 3 times today, kind of hoping I would not mess this video up. So now you'll see him use this, and that's why I wanted to get this out of the way. Now, without completely crashing my computer, I got to get us over to the video. So buckle up. We're moving, I'm hoping, over to the video. TV, Elmo off. Look, we did it. Okay. This is my friend here, TU, and so I'm going to start this video, and again, I really like it, and I'm going to keep my scratch paper over here, but I'm not going back over there where we did the area calculations unless I feel like it's necessary to calculate something in front of you. So let's start this, and again, I'm going to pause it from time to time, perhaps, and kind of go back through it to make sure you're understanding what my friend here is talking about. So let's start.
Big, heavy machineries are able to move such heavy loads. Mining equipment, construction machinery, and any other industrial or mobile machinery that requires movement of heavy loads are often using hydraulic technology. To understand the basics of hydraulics, we can start by understanding pressure and Pascal's law. Pascal, as in French philosopher and scientist Blaise Pascal, who was born in June 19, 1623 in Clermont-Ferrand, France, and died in August 19, 1662 in Paris, France. Pressure is force exerted over an area. And Pascal's law says pressure applied to an enclosed fluid will be transmitted without a change in magnitude to every point of the fluid and to the walls of the container. The pressure at any point in the fluid is equal in all directions. For example, assume we have a 1-inch cube container. Each side of the container is 1 inch long, and each face of the container will be 1 square inch. And let's say we have a lid that seals the container, yet it is able to slide up and down inside the container. If we fill the container with water and we close the container and try to push it down with the lid, the amount of force pushing down on the container will be transmitted without a change in magnitude through the water pushing in all directions against the walls of the container. If you apply 10 pounds of force pushing down on the lid of the container, you will get 10 pounds of force pushing in all directions against the walls of the container. The units to measure pressure are PSI, meaning pounds per square inch.
Now, uh, if we look at this, he's saying 10 pounds are going to be pushing out, and then he says 10 pounds per square inch. So what you're going to come across in the next couple of slides is formulas that to find pressure, you take the force, in this case 10 pounds, and you divide it by the area, in this case is 1, and that gives you pressure in pounds per square inch. So 10 pounds divided by 1 square inch is 10. So the PSI, pounds per square inch, pushing out in all directions, is 10 pounds per square inch. That's where that comes from. Let's move on.
In this example, we will have 10 psi of pressure pushing in all directions. Now, let's say we have a different container with two sides open. One side is 10-inch square area for the opening, and the other side has 50 inches square for the opening. If we push down with 100 pounds of force against the 10-inch square area, it will create equal pressure within the container pushing in all directions, and we will be able to lift a load of 500 pounds standing on the 50-inch square area of the container.
How is that? That's like, uh, where did that come from? Well, I'm not going to go into it. Let's let him finish it.
Consider the hydraulic formulas of F equals P times A, or P equals F divided by A, in which F equals force measured in pounds, P equals pressure measured in pounds per square inch, and A equals area measured in square inches. If we have 100 pounds of force divided by 10-inch square, it will be equals to 10 psi.
Now, you remember that that formula is to get pressure, right? You divide the force by the area. In this case, the force is 100 pounds and the area is 10 square inches. So you see, this is what he's doing. He's using force, 100 pounds, divided by area, 10 square inches, and it's giving him 10 psi. Now keep in mind, I want you to look at this vessel, let's call it. It's not sealed, but it's holding this liquid. This is all liquid. It's hydraulic oil, let's say. So this volume over here, he's going to push it down and it's going to displace liquid into here. He's going to push it down like, I don't know, I don't remember, 50 inches or something like that, or but it's only going to move this 10 to 1. Now he's going to talk about this kind of fast, but notice how big 50 square inches is and how small 10 square inches. So even though we're lifting a lot of weight here, we're pushing down with 100 and lifting 500, it's going to cost us movement. In other words, distance on and in an actuating rod and a cylinder, that matters. So we're going to get a whole lot more force, but we're going to lose a little distance. Now, just remember that and watch for that. I think that's what he's going to do.
Now, if you take 10 psi times 50 inch square from the larger opening, it will be equals to 500 pounds of weight that you will be able to lift with just 100 pounds of effort coming from the smaller opening of the container. In this example, we are able to lift 5 times more the weight in relation to the effort pushing down on the fluid. However, we are only able to move 500 pounds, 1/5 of the distance in relation to the movement of the 100 pounds weight. If we push the 100 pounds weight 50 inches down, and we only move the 500 pounds weight 10 inches up. This is because the fluid displacement is the same on both sides of the container. 10-inch square area from the smaller opening times 50 inches round down distance equals 500 cubic inches. Same as 50-inch square area from the larger opening times 10 inches run up distance equals 500 cubic inches. In a hydraulic system, if you want to lift 4,000 pounds of weight and you have a cylinder that is 2-inch bore diameter by 1-inch rod diameter and 5-inch stroke is the distance in which you can extend and retract the cylinder, and the inch square area that you're going to use to push the rod in the cylinder would be 3.1416 inch square. The formula to calculate the area is diameter square times 0.7854 equals area in inch square. If we want to lift 4,000 pounds with this cylinder, we will use the formula P equals F divided by A. So we have 4,000 pounds divided by 3.1416 inch square equals 1,273.2365 psi. If we input, say, 2.042 GPM or gallons per minute into the cylinder at a minimum of 1,273.2365 psi, then the cylinder will extend and lift 4,000 pounds. But what if you want to lift 8,000 pounds instead? Then you can say 8,000 pounds divided by 3.1416 inch square equals to 2,546.4731 psi.
Now, I'm just going to take a breath here. There's not much going on in up here, really. It's just taking the diameter and multiplying it by 0.7854, and that gives you that 3.1416, which is your area down here. But notice one thing. You got 4,000 pounds. It will lift at 1,273.2365 pounds per square inch. If you want to lift 8,000 pounds, then you would do the same thing. Divide 8,000 by the area, this, and you would get this much PSI. And see, everything's almost double. This is what is a 2-to-1 force factor. So you look for things like this that double. I think we're going to see a little bit more from him on this. I just wanted you to be sure you're caught up, and I hope I'm not making things more complicated. Well, I kind of hope. So let's see what else he's going to say.
you could just increase the working pressure. But, big warning, before increasing pressure in the system, you need to make sure all hydraulic components are rated to the pressure you're working with, or your system might just blow up like this. Boom! So, if you don't want your hydraulic system to blow, you might just want to keep the maximum pressure within the pressure rating of your components. Say this particular system has a max working pressure of 1500 psi. Then you will need a bigger area cylinder to lift the higher load to stay within the limits of your system.
I want you to get this, and I kind of want to apologize for interrupting him in the middle of the sentence, but your system that you're working with has a maximum pressure of 1,500 pounds, so he's got to make some changes uh, to get this pressure right here down uh, well under these, because see here, he's got 2,000 uh, pounds of pressure required for the 8,000. Now he can't do that. So what are his options? Well, remember, it's force is pressure is force divided by the area. So he can get a bigger area piston and probably get by without having to increase the PSI, and I think that's what he's going to do. Let's watch and see. So he won't jeopardize this parameter of 1500 psi for the system. Let's see.
Say a cylinder that is 3 1/4 inch bore by 1 3/4 inch rod by 5-inch stroke. The working area to push the rod in this cylinder will be 8.2958 inch square. That is a rounded figure. We have 3.25 square times 0.7854 equals 8.2957875 inch square for the area of this new bigger cylinder. The new numbers in the formula to calculate pressures for this cylinder will be 8,000 pounds divided by 8.2958 inch square equals 964.3434 psi. So if you input 2.042 GPM at 964.3434 psi into your new cylinder, then the cylinder will lift a load of 8,000 pounds. But if you will notice, the bigger cylinder moves slower than the smaller cylinder, and that is because you're using the same flow rate of 2.042 GPM for both cylinders. The bigger cylinder has more area, and it will take more time to extend the cylinder with the same flow rate as the smaller cylinder.
Now, we're about to end this thing, but this is really important because you're going to read in your book where it says the flow rate is of the pump flow rate is like directly proportional to activator or actuator speed. So that's not always true. The cylinder size, like he just said, makes a difference. So if you wanted to increase the speed over here, you would probably have to up the gallons per minute here. If you wanted this to operate at this same speed, don't change this, but get a more pump that would pump more than 2.042 gallons per minute. Excuse me. Now he's about to finish this up, which will finish up this video. And so let's watch.
How can we calculate proper flow rate for the bigger cylinder to move within a certain speed that we want? Please make sure to like and subscribe. as
Okay. That's the end of the video.